Hi Year 12, this is the second video for the solutions to the 2022 Maths Advanced HSC paper. In this video we're going to look at questions 11 through to 22. Question 11a. The table shows the types of customer complaints received by an online business in a month. You can see we have different complaints here. We have a frequency column and a cumulative frequency column and a cumulative percentage column. And we're asked to find the values of A and B. Now recall that the cumulative frequency is just the adding up of the frequency column line by line. So the 98 goes across here, then we add on 62 to get A. And so 98 plus 62 is 160. A is equal to 160. Now to get our cumulative percentage, I'm just going to create a fraction. So it's going to be 192 out of 200, and then we just turn that into a percentage. So just grabbing my calculator, I'm going to do 192 divided by 200 times by 100, and that is 96%, and so B is 96. Part B, the data from the table are shown in the following Pareto chart. The manager will address 80% of the complaints. Which types of complaints will the manager address? This is a really easy question. Might seem a bit of a strange question to you, but it's based on the principle, the Pareto principle, that 80% of the problems come from 20% of the causes. So we're trying to figure out what causes the 80% of the complaints. Now if we have a look here at the cumulative percentage, 80% is sitting here, and that is the first two columns. And so the answer to this question is stock shortage and delivery fee. Question 12. A student believes that the time it takes for an ice cube to melt, m minutes, varies inversely with the room temperature. So remember, varies inversely means 1 over T. The student observes that a room temperature of 15 degrees Celsius, it takes 12 minutes for the ice cube to melt. Part A, find the equation relating M and T. So here's our inversely proportional relationship, and this of course is the same as M is equal to some constant, we'll call it K, multiplied by 1 on T. Now we're going to substitute these pair of values in and work out what K is. So M is 12, K we don't know, and T is 15. Multiply both sides by 15, K is equal to 180. So therefore, here's our equation, M is equal to 180 multiplied by 1 on T, or 180 on T. 12b, by first completing the table of values, graph the relationship between the temperature and time from T equals 5 degrees to T is equal to 30 degrees Celsius. So we've got M is equal to 180 divided by T, and we're just going to substitute in various values for T. So the first one, 180 divided by 5, and that's 36. And then 180 divided by 15 is 12. And then finally 180 divided by 30, which is 6. And plotting those values. So we've got 5, 36, which is here. We've got 15, 12, which is here. And 36. Hard to see, isn't it? I don't think I've got any chance at all of being able to draw this in, but it is a decaying relationship, so it's like an exponential coming down. Yep, maybe I can do it. So it looks like that. Question 13. Use two applications of the trapezoidal rule to find an approximate value of the integral between 0 and 2, the square root of 1 plus x squared dx. Give your answer correct to 2 decimal places. All right, two applications of the trapezoidal rule. That means two trapeziums. So if we've got our curve, don't know what it looks like, and we're going between 0 and 2, Then I'm going to split it into 2 strips. Right, so our x value is going to be 0, 1, and 2. Now I don't like the formula that's given for you on the formula sheet, so instead I prefer to use this one. You can do it however you want. H over 2, this is the way we used to do it. And then f of 0 plus f of 2, so that's the first one and the last one, plus 2 times any of the middle ones, which is just 1. Now this h is the width of the strip, and the width of the strip quite obviously is 1. So this is a half. F of 0, so substituting in here gives us the square root of 1. F of 2 is the square root of 5 plus 2 times the square root of 2. And putting that in the calculator, what are we going to get? 0.5 times 1 plus root 5 plus 2 times root 2, close my brackets, and I get 3.03224, which to 2 decimal places is 3.03. Question 14. The graph of y equals k sine of ax is shown. What are the values of k and a? So let's start here because it's nice and easy. That, of course, is a vertical dilation. Now, sine normally goes between -1 and +1, but here it's going between 4 and -4, and so it's been stretched out, scale factor 4, k is equal to 4. Now here, this one is a horizontal dilation. Now, this affects the period, so I'm actually going to write the formula. Period is equal to 2 pi on n. N is the number in front of x, so in this case it is a. All right, how long does it take this graph to get through one cycle? 6 pi, can you see that? So it's equal to 6 pi. All right, let's switch these guys around. A is equal to 2 pi on 6 pi, which is 2 on 6, or 1/3. A is 1/3. Question 15. In a bag there are 3 6-sided dice. 2 of the dice have faces marked 1, 2, 3, 4, 5, 6. The other is a special die with faces marked 1, 2, 3, 5, 5, 5. One die is randomly selected and tossed. What is the probability that the die shows a 5? So we need to consider both cases. So the probability that we're going to get a 5 is going to be equal to, what is the probability that we choose one of these dice? Well, that's 2 out of 3. And then the probability that it is a 5 is 1/6, or the probability that we choose this die is 1/3, and the probability that we get a 5 in this case is 3 out of 6, or a half. And just grabbing my calculator, we get 2 divided by 3 times 1/6 plus 1/3 times a half is 1/6. And our answer is 5/18. Part B, given that the die shows a 5, so this is conditional probability, what is the probability that it is the special die? So using our formula, this is the probability it's a special die and it's a 5, divided by the probability that it is a 5. Okay, we already know the probability that it's a 5. That is 5/18. The probability that it's the special die, well, that's 1/3, times, and the probability that's a 5 is a half. So doing that on the calculator, on the top I can see I've got 1/6 divided by 5/18, which is 0.6, or 3/5. Question 16. The parabola y equals x squared meets the line y equals 2x plus 3 at the points -1, 1 and 3, 9 as shown in the diagram. Find the area enclosed by the parabola and the line. So we want to work out the area under this curve here, the straight line, between -1 and 3, and then subtract the area under the parabola. So let's set that up. Our area is going to be equal to the integral between -1 and 3 of the straight line, which is 2x plus 3, take away the parabola x squared dx. Okay, let's integrate. So we're going to get 2x squared divided by 2, which is x squared, plus 3x, take away x cubed on 3, and in between -1 and 3. And we need to substitute in the 3, so 3 squared is 9, plus 3 3s are 9, take away 3 cubed is 27 on 3. Subtract. Now, because I've got multiple terms here, I'm going to put this in brackets. -1 all squared is 1, plus 3 times -1 is -3. And then I've got take away -1 cubed. -1 cubed is -1, so that's going to make positive 1/3. And this is 9 plus 9, take away 9, they cancel out. All right, grabbing the calculator, I have got 9, take away bracket 1 minus 3 plus 1/3, close our brackets, it's 10 2/3. Now we are asked for the area, so I'm going to write units squared. Question 17. Cards are stacked to build a house of cards. A house of cards with 3 rows is shown. A house of cards requires 3 cards in the top row, so that's here, 6 cards in the next row, and each successive row has 3 more cards than the previous row. So this should already be telling you that this is sequences and series question. And 3 more cards in the previous row, this is an arithmetic series. Part A, show that a house of cards with 12 rows has a total of 234 cards. So we want our sum of an arithmetic series. So Sn is equal to n over 2, 2a plus n minus 1d. All right, we want 12 rows. Sum of 12 rows is 12 over 2. In the first row, there are 3 cards. N minus 1 is 11. And each successive row has 3 more cards, so D is 3. Okay, into the calculator, hopefully we get the answer. 6 plus 11 times 3 brackets equals 234. And question B, another house of cards has a total of 828 cards. How many rows are in this house of cards? So again, we're going to use the sum formula. S of n is n over 2. 2a plus n minus 1d. Now, we know the total number of cards is 828. We don't know what n is. We know a is 3, and we know d is 3. So let's tidy this up a bit. So I'm going to start by doing 828 times 2 on the calculator. What is that? 1656. 1656 is equal to n, brackets, 6 plus 3n minus 3, which is equal to n multiplied by 3 plus 3n. And I'm going to tidy this up into a quadratic. So we've got 3n plus 3n squared. I'll subtract the 1656, put it all equal to 0. Now you could try and factorize that if you want to. In fact, it's probably got a common factor of 3. It does. So let's tidy it up a little bit. So we've got n squared plus n minus 552 is equal to 0. I'm just going to use the quadratic formula. So I'm just going to come up here. It's just easier. N is equal to minus b plus or minus the square root of b squared minus 4 times a times c all over 2a. Now, I'm not going to want the negative there because we can't have a negative number of rows. So I just need to do positive on the calculator. So we've got -1 plus square root of 1. It's actually going to be plus, isn't it? Plus 4 times 552 all over 2. And the number of rows is 23. And I would be looking for a whole number there. So nice little check. If you ended up with a decimal there, do it again because you made a mistake. Question 18, differentiate y equals x squared plus 1 all to the power of 4. Okay, so we've got a chain rule here, don't we? So dy dx equals, I'm going to differentiate the outside function, which is a power rule. 4 comes down, leave this inside alone, to the power of 3, multiplied by the derivative of the inside function, which is 2x. And just tidying it up, we end up with 8x, x squared plus 1 in brackets cubed. Hence, or otherwise, find this integral. All right, it's really close to this, isn't it? It's just got an extra 8 there. So I'm just going to amend this slightly. Here's what we've got. I'm just going to play a matching game. I want 8x, don't I? I can't just do that, so I need to adjust it. 1/8 times 8 is 1. So I haven't changed anything. Now, I happen to know that the integral of this is this. So there's our answer, x squared plus 1 all to the power of 4 plus c. Question 19. The graph of the function f of x is equal to x squared is translated m units to the right, dilated vertically by a scale factor of k, and then translated 5 units down. The equation of the transformed function is g of x is equal to 3x squared minus 12x plus 7. Find the values of m and k. Alright, so let's start with f of x and do these transformations. So we're going to get g of x is equal to, translating m units to the right, remember it's going to be x minus m all squared. Then I'm dilating vertically, scale factor k, and then translating 5 units down. And this is going to be equal to 3x squared minus 12x plus 7. Now you could work on this side and put it into vertex form, but it will be a bit yuck. So instead let's expand this out. K, x squared minus 2mx plus m squared minus 5 is equal to kx squared minus 2mkx plus km squared minus 5. All right, we can immediately see that k is going to be equal to 3. And then looking at the terms in x, here we've got negative 12x and negative 2mkx. So equating those coefficients, I get negative 2mk is equal to negative 12. And we know that k is 3, so that's negative 6m is equal to negative 12. And so m is equal to negative 12 divided by negative 6, which is 2. Question 20. The scientist is studying the growth of bacteria. The scientist models the number of bacteria n by the equation n of t is equal to 200 e to the 0.013 t. T is the number of hours after starting the experiment. What is the initial number of bacteria in the experiment? Remember, initial means t is equal to 0. So I'm just going to substitute 0 in there. I'm going to get 200 e to the 0, which is 200. Part B, what is the number of bacteria 24 hours after starting the experiment? Now at this point, I would always go and look at what is given. T is the number of hours. I'm just checking my units to make sure they haven't tricked me. So I just want to substitute in T is 24. Nice easy question again. 200 times e to the 0.013 times 24. Putting in the calculator, what do we get? 200 times e to the power of 0.013 times 24 is 273. The number of bacteria, it doesn't say how many decimal places or anything to give. It's 273.23, approximately 273 bacteria. And then part C, what is the rate of increase? So that's a derivative in the number of bacteria 24 hours after starting the experiment. So we want dn dt. And 200 stays. Now, this is just a chain rule. The outside function is an exponential. E to the x stays the same, so I'm going to leave it alone. E to the 0.013t times by the derivative of the inside function, which is just a power rule. Derivative of 0.013t is 0.013. What is the rate of increase in the number of bacteria 24 hours after starting the experiment? So I want to substitute in t is equal to 24. So at t is equal to 24, dn dt, running out of room, just substituting in 200 times e 0.013 times 24 times 0.013 is equal to 3.55. What does that mean? This is 3.55 bacteria, just call them B, per hour, because it's a rate. 21A. Eli is choosing between two investment options. Option 1, he deposits a single amount of $40,000 today, and he earns interest of 1.2% per annum compounded monthly. Option 2, depositing $1,000 at the end of each quarter, earning interest of 2.4% per annum compounding quarterly. All right, a table of future value interest factors for an annuity of $1 is shown. What is the value of Eli's investment after 10 years using option 1? Okay, so this is a single amount, $40,000 today. Interest of 1.2% per annum compounded monthly. So R is going to be 1.2 divided by 12, which is 0.1%. And after 10 years, and we want it monthly, so N is equal to 10 times 12 is equal to 120. Let's just move that. So A is going to be equal to, he's investing $40,000. 1 plus 0.1% interest to the power of 120 equals 40,000 times 1.001 to the power of 120, 47,097.17. Part B, what is the difference between the future values after 10 years using option 1 and option 2? So option 1 was 45,097.17. Now option 2, in this case he's depositing $1,000 as an annuity, and it's 2.4% per annum compounded quarterly. So R is going to be 2.4 divided by 4, which is 0.6%, which is this guy here. And how many quarters are there in 10 years? There are 40, so that's this number here. Now that's for $1. He, of course, is depositing $1,000. So here's option 2. We want 1,000 lots of 45.05630. Timesing by 1,000, we move our decimal place. So option 2 is going to be worth 45,05630. All right, so he's actually better off doing option 1. What is the difference between the future values using option 1 and option 2? So it's just a simple subtraction, isn't it? Let's look at that number in my calculator. So take away 45,056.3. The difference is $40. $40.87. 22. Find the global maximum and minimum values of y equals x cubed minus 6x squared plus 8. And we're given a range of values. Now, maximum and minimum, it's all to do with differentiation, obviously, but when we have got a restricted domain, we also have to check the endpoints. So x equals -1 and x equals 7. But let's start by differentiating. So dy dx is equal to 3x squared minus 6 2s are 12x, and that's it, equals 0 when, let's factorize this, 3x, x minus 4 is equal to 0. So x is equal to 0 or 4. At x is equal to 0, what are the y values? Y is equal to 8, and at x is equal to 4, y is equal to, wow, 4 cubed minus 6 times 4 squared plus 8 equals 4 cubed minus 6 times 16 plus 8, -24. All right, so potentially this is the max and this is the min, but we do need to check. So we also need to work out what y of -1 is and what y of 7 is. Okay, -1. -1 all cubed is -1. Take away 6 lots of -1 all squared is 1, plus 8 is 8 takes 6 is 2, that's 1. And then y of 7. 7 cubed minus 6 times 7 squared plus 8 equals 7 cubed minus 6 times 49 plus 8 is 57. Okay, what does that mean then? In terms of the minimum, that is the minimum, the global minimum. But in terms of the maximum, that is a local maximum there, but here is the global maximum. So global max is 57 and global min is -24. Okay, that's it for this video. In our next video, we'll cover questions 23 to 32.